Hi! Welcome to the second part of our lecture on rectilinear motion revisited and antiderivatives involving logarithmic and exponential functions. So this is the second part of our video and we will tackle the last two topics. So let's start with antiderivatives of other circular functions. So we know what integral of sine u du and integral of cosine u du are from 4.1, lecture 4.1. So do you remember what they are? Integral of cosine u du is sine u plus c. How about integral of sine u du? It's negative cosine u plus c. So how do you know again if your answer is correct? It's very easy. All you have to do is differentiate your answer and then you should get the expression inside the integral. So the derivative of sine u is cosine u, so that's correct. The derivative of negative cosine u is negative, so positive sine u. Alright. So question is, how about the other functions? How about tangent, cotangent, secant, and cosecant? What are their formulas? So this is what we will tackle now. So we will prove the formula for tangent u, and for the others, you can try to see them for yourself. So integral of tangent u du, we will write this as sine over cosine. And then you remember our formula for today, right? It is, we can we have already used the letter u, so we're not using it again. We're going to use a different letter. So we let v, okay, let v equals the denominator, right? So we can do that. So let v equals cosine u, and then let's hope that this part will be what? Sine u, no? So dv will be sine u, and that's true. dv is negative sine u, in fact. So the negative is just a constant. You can put that on the left side. So you'll have sine u du can be replaced by negative dv. Okay, so the negative is constant, so it will go out, and then integral of 1 over v dv is just ln of absolute value of v. Then going back to the original variable, which is u, then you'll have ln cosine u. And that is the formula, but we can make it nice. We can make the negative disappear. So how do you do that? So what we can do is, remember your laws of logarithms, since ln is a logarithm, right? So there's a law of logarithm that says that the multiplier will become the power, right? So the negative 1 here will become your power. So we can write it this way. Okay, so then what is cosine u raised to the power negative 1? Is it cosine inverse? Is it the inverse cosine? No. Okay, so it should be the reciprocal of cosine u. And the reciprocal of cosine u is 1 over cosine u is secant u. Okay, and that is another formula. So there are two forms, but we prefer the positive one because, you know, it's so that you don't have to trouble yourself with the negative sign. Just try to remember the positive ln secant u. So this is our formula. But you can use any of them, whatever you like. Okay, so both of them are correct. So for the others, we have cotangent u. This formula is similar to the proof of tangent u. Then for the last two, they have quite different proofs, so you can check them out if you want. So now let's try to do some exercises. So first, do you remember our comment from the first video? If you haven't seen that, please, by all means, please watch that first. We discussed many things there. So one of them is, do you remember what happens when you have a new antidifferentiation formula? We said that, yung possible choices for you, dumadami. Okay? So, but in this case, where is u located in these new formulas? Tangent u, cotangent u, secant u, cosecant u. So, these are all what? Inner functions, right? So, in other words, in this case, wala namang masyadong nadagdag, no? So, that means if you have an inner function, then it can be a possible choice for you, okay? And then you just hope that whatever is outside your target expression, hopefully that will be eaten up by your du, okay? So let's try the first number. So here we can see that you have an inner function, x to the 4. So you can let u equals x to the 4 and then hope that x cubed dx will be part of du, right? Para mag-isa lang yung integral of cosecant u du. Okay? So let u equals x to the 4. Indeed, our du is 4x cubed dx. And if you remove the constant and put it on the left, so divide by 4, then 1/4 du is x cubed dx. So we now replace x cubed dx with 1/4 du. Then replace this with cosecant u. Okay? And then you will have this. So yung 1/4 will go out of the integral. We'll be left with this one. And what is the new formula? We have ln cosecant u minus cotangent u. So you get this. And don't forget to go back to x, original variable. And that's the final answer. Easy, right? Okay, let's go to the next. So, what about this one? So, before you do anything rash, first, you have to check, is there an inner function? So, the answer is yes. The inner function is x over 2. So, you can start with that. You can let u equals x over 2. So, du is 1/2 dx, or in other words, 2 du is equal to dx. So, replace dx with 2 du, then your constant 2 will go out of the integral. And then what will be left here? You will have sine u plus 4 over cosine u. So how do we answer, or how do we proceed? Okay? So definitely, can we integrate the numerator and denominator separately? So integral of this divided by integral of cosine u? No. Okay, so remember that we don't have a quotient rule or a product rule in antidifferentiation. All we have is sum rule. So what do we do? So remember this kind of form, a plus b divided by c. Okay? We can separate this into a sum by dividing each addend in the numerator by the denominator. So you'll have what? Sine over cosine plus 4 over cosine. And sine over cosine is tangent, while 4 over cosine is for secant u. So, right? The reciprocal of cosine is secant. So now, this is a sum, and what's good about sums is that we have a rule for sums in antidifferentiation. That means you can integrate each one individually. So, what is the integral of tangent u du? It's this one, and integral of secant u is that one. Okay? And then the 4 just goes out of the integral. So, just be mindful of the times 2. This times 2 is multiplied to the entire sum. So, make sure that it will be reflected in your in each addend. So this will be 2 times tan, then this will be 8 times secant. So you should have something like this. So if you will not distribute that, then just make sure that you have the grouping symbol. Okay? So 2 times grouping symbol, and then inside the grouping symbol is your sum. Okay? And then that is also correct. So integral of tan u is ln secant u. This one. And then integral of secant u is that one. And then copy constant 4. Okay, and then we just go back to x. Okay, so that's it. So, and if you want to distribute, that's fine. If you don't want to distribute, that's also fine, as long as you have the grouping symbol. Okay, All right, that's the answer. And don't forget the plus c. So now let's go to antiderivatives of exponential functions. So what do you think is the answer for this one? So can you think of a function whose derivative is e to the u? Yes, the correct answer is this is also e to the u, right? Because the derivative of e to the x is itself, okay? So how about a to the u? Then this is just, okay, a to the u over ln a. So if you want a quick explanation, then you can just differentiate this. What's the derivative of a to the u over ln a? Remember, ln a, if a is constant, right? Then ln a is also constant. So that means you have your constant times a to the u. What is the derivative of that? Okay. Then you will have 1 over ln a, copy, okay, copy 1 over ln a, and then derivative of a to the u is a to the u times ln a. So ln a will cancel, and then you will get a to the u. So this is correct. Okay. Some examples, very simple. What if you don't have, okay, this is just x. So notice, is there an inner function? Okay, none, right? So here, the a, mind the formula, the a can be any constant, right? Here, the e is the constant e, okay? So here, you have 7 to the x. That means your constant a is 7, all right? And then your u is just, well, it's just x, okay? So there's no need for substitution because you don't have an inner function, right? So 7 to the x dx following this formula will give us what? 7 to the x divided by ln 7. So, okay, be careful. It's not over ln x, it's over ln 7. So just follow the formula. Plus c. That's the answer. How about this one? So notice that instead of e to the x dx, instead of x, it's now something else. So you have now an inner function, 1 minus 4x. So now, this is the time that you can use substitution. Okay? So you can now let u equals your inner function, 1 minus 4x. Right? And then, what will be your du? Du is negative 4 dx, and then divide by the constant negative 4, you get this one. So replace dx with negative 1/4 du. The constant negative 1/4 goes out of the integral. Then replace the exponent with u. Okay. Then what is the integral of e to the u itself? So you will get this. And then going back to x, you get this. And that's the final answer. So do you remember again what we said? Whenever you have new formulas, dumadami yung possible choices natin for u kapag nagsa-substitution tayo. So, in this case, ano yung nadagdag? Ang nadagdag sa atin ay your u can now be the exponent. Okay? So, if you see that the exponent is not simple, it's not just x, it's something else, then you can let u equals the exponent. Okay? So, this is provided that the base is constant. Okay? So, dapat constant yung base. So, like e or like any constant a. Okay? So, let's try another one. So, notice this one is also exponential. Base is constant. Base is constant. So, what is the method for this one? So, question, can we integrate this 1 by 1? So, integrate 2 to the 2x and then integrate 5 to the x separately and then just multiply that. The answer is no. So why? Because there is no product rule for antidifferentiation. So you cannot integrate them individually if they are products. Okay? So what do? What we try to do is combine them as one expression. Okay? So make the appearance change. Okay? So how do we combine this as one expression? So remember, if you have, the laws of exponents, if you have first 2 to the 2x, you can write that as 4 to the x, right? Because this is 2 square raised to the power x, right? Right? Because x raised to the m raised to the n is just x raised to the product of m and n, alright? So that's it. So how about these two? 4 to the x times 5 to the x, if you have common power here, then you can combine the base by multiplication. So you will have a to the x times b to the x is ab raised to the x. So you have 20 to the x. Then this is now constant raised to the x. So we can now use the formula for our exponential. So this will be 20 raised to the x divided by ln 20 plus c. And that is the answer. Okay? No need for substitution because you don't have a particular, you don't have an inner function that's different from x. So how about this one? So notice that they are different. So in the previous number, both are exponential. But for the next number, this is exponential and this is algebraic. Okay? It's not exponential. So baligtad. Here, you have the base is constant. Here, the base is a variable. Okay? And here, the exponent is variable. And here, the exponent is constant. So, okay, it's different. So what do we do here? So again, notice that the exponent here of your exponential is not simple anymore. It's now some inner function. So we can maybe let u equals the exponent. Let u equals 5 minus x cubed. Then du is negative 3x squared. Then divide both sides by the constant negative 3. Do you see x squared dx in the original? Yes. It's this and that. Therefore, you can replace x squared dx with negative 1/3 du. Then replace this with 2 raised to the u. Then, constant goes out of the integral. Then you will have this. So what's the formula for 2 to the u du? It is just 2 to the u over ln 2. Okay? Then go back to x. Then you will have negative 2 to the 5 minus x cubed. Okay. And that's it. No need to do to do any more simplifications. Okay na yan. Right? And this is the last example. This is a bit hard. So let's see what we can do here. First, well, you can't let u equals x. That's totally useless. Okay. So maybe one way to do this is first, can we write this as a sum? Okay. If you remember, if this was a plus b over c, then we can write that as a sum. But this looks like a over b plus c. So can we write that as a sum? The answer is no. Okay. So that is not true. So you cannot write this as a over b plus a over c. So that is incorrect. So what do we do instead? Can we try to use substitution? We can't really, well, even if you try let u equals negative x, that will also be not useful. Okay? So what can we do here? Well, we want to change the appearance of this one. So if you remember your laws of exponents, there is one rule there about negative exponents, right? So you can make use of that. So if you write this as 1 over e to the x, and you rewrite the fraction and simplify it, then you will get something else, right? You will get a nice, okay, a different form, okay? So, or in other words, one way you can also achieve the same thing is if you multiply by e to the x over e to the x. That will also give you the same result. Okay? So, if you multiply e to the x over e to the x, then you will get this. Okay? So, it's the same as if you write this as 1 over e to the x and then, add the fractions and then divide. Then you will also get exactly the same thing as this one. Alright? So, now the form looks different. It looks different than before. So, what can we do for this one? Can we write this as a sum? Still no. So, what do? Can we let u equals 2x? Possible, but there's something that's even better than that. And what is it? You can let u equals the denominator. Oh, why? Let u equals the denominator. Why will this work? If u equals the denominator, then what formula are you going for? You're going for the 1 over u du, right? So that means your hope is that e to the 2x dx, okay, the one in the numerator, becomes du. But what is du for this one? The derivative will just be, okay, this will be 0, this will be e to the 2x, and then by chain rule times 2. So if you divide by 2, then you will be left with e to the 2x. And that's good news. Can you find that in our original? Yes. So this will be replaced by 1/2 du. So that will work. You will have 1/2 du and 1 over u. 1/2 goes out, so you get this. You'll have ln of absolute value of u going back to x. You will get this one. Yay! And that's the answer. So here are some other exercises that you can solve by yourself. And I hope you enjoyed this video. And I'll see you again in some other lecture video of Math 21. So stay safe and stay healthy. And see you. Bye!